Hello class, welcome to week 3, and in this week you are reading chapter 4 in the text. And chapter 4 gets very technical as it talks about networks and the relations of machines across large distances to each other. So I just wanted to kind of recap a little bit some of the key concepts that the text was talking about. Networks are really crucial to a business's success because if your network fails, you lose data, or it works too slowly, you're going to lose business. And as we've been talking about all along, the key to business these days is data. So let's talk about what data actually is. A computer, and both the hardware and the software that's involved, is really dealing with bits and bytes. And so a bit is information is just a 0 or a 1, and the series of zeros and ones creates data that the machine then reads and translates into something that you see. So everything that your computer does, including, I'm recording this on QuickTime this week instead of iMovie, it is translating my voice and the images coming through the camera into zeros and ones and reconstituting that in another part of the machine. So when machines are linked together, they have to be set up so that they understand each other. Just like if I called some random phone number in the country of Germany and I don't happen to speak German and they don't speak English, we're really not going to accomplish too much over the phone. So machines have to be using the same, in machine language, protocol, meaning language, the same rules and procedures to communicate with each other. So you have protocols within network, meaning if you have a company and you have 5 offices, there is a computer in each office and probably a server, which is sort of like a supercomputer in another location. Usually there's a server room, a closet, or a large air-conditioned space to keep that machine. And they all have to be working on the same protocol. So if you're communicating outside of a local area network, it's considered to be a wide area network. So the internet is an example of a really massive wide area network, or we also call them WANs. So it's LAN and WAN when you're talking about the acronyms. So the internet is really just a interconnected series of machines, of computers. And you can almost think of the connections between them as like being plumbing. So inside your house or apartment, you have a water source that's coming into the building, and the water moves through the pipes and out the sink or into the ice maker in the refrigerator or whatever. And those pipes can only handle so much water at once. So houses built a code now, they can handle 6 gallons a minute in the pipes. If your well or the city water produces more than that, it doesn't matter because you can only push that 6 gallons through at once. And the internet is the same way. These connections between machines, whether it's copper wiring, whether it's fiber optic wiring, or whether it's electromagnetic waves like wireless transmissions, there's only so much that can be transmitted at one time. And that's why the book talks about bandwidth, that your location can only handle so much data at once. The internet in general can only handle so much data at once. And so what's moving across these pipes, if you will, what we're calling pipes, are little packets of data. So again, it's these little bits, these zeros and ones, and they're bundled together and they're fired out across this pipe. And so if there's other information coming from the other direction, or part of the connection goes down, like one part of the pipeline goes offline, those packets can be rerouted somewhere else. And so the packets are put together again at the other end and put in order and then read by the machine at the receiving end. So that's kind of how that whole thing works. And again, just like you have a protocol or a language within your local network, the internet or the wide area networks also have to have a protocol. So when you look at the address of a website, you will see that usually it starts with HTTP or something like that, and that's Hypertext Transfer Protocol. That's just declaring what the language is. So if I'm going to call someone in Germany, I text them ahead of time and say, we're speaking in German today, or we're speaking in English today, and then we've agreed upon how we're going to communicate, and that's how that works. So to go back again to an internal network, you have master machines and sort of slave machines. That's a term that is used in IT. The book talks about servers and clients. Again, a server is sort of a souped-up computer, and it handles some advanced functioning that the regular computer doesn't. So some of the programs or apps might actually be run off of the server instead of the local computer. And the amount of power that the local computer has, the individual node, will define whether it's a fat client or thin client. So a fat client can run advanced software whether the network is on or off, and a thin client can only run that if the server and the network is working because it's running that off of the server. And you'll see that a lot of cloud-based computing is sort of set up that way. Your personal machine doesn't need to have as much computing power or random access memory or anything like that, because it's on the server. However, if there's solar flares and the internet is slowed down that day, then you have a hard time accessing that material. So the text will be going into more of that stuff later on down the road, sort of the advantages and pitfalls of cloud-based computing. So besides fat clients and thin clients, you can also have an arrangement that's called peer-to-peer, meaning each computer is both a server and a client. And the text talks about the advantages and disadvantages of that. And so also I just wanted to point out that people think they are completely secure on the web because they figure, oh, I'm at my house and no one's watching what I'm doing, and I'm using a search engine or something that's open to everyone, or I'm looking at YouTube. Almost everything you're doing is being recorded in some way, and your computer has an internet protocol address or IP address, just like your home has a physical address. So that IP address follows you around on the internet, and that's why you receive targeted ads from stores around your local area. So, or sometimes you'll see a posting that says, well, the weather in Meriden today is sunny and 80 degrees, and you say, wow, that's kind of funny that I keep seeing all these things popping up from Meriden. Especially if you don't live in Meriden. And the reason for that is if you have an internet provider like AT&T or Comcast or whatever, they will also have an IP address attached to your internet access for that day. And those addresses are not static, they are dynamic, which means they change all the time. So if you are in Torrington and you see a lot of ads for Waterbury, it probably means that the IP address that the internet provider is using for you is actually in Waterbury that day. So there's a couple of different IP addresses attached to your machine, and then everything that you access on the internet also has an IP address. So when you look up at the Uniform Resource Locator, or URL, which is the address of the website, what you type in, like yahoo.com, the real address is sort of hidden behind that. It's a series of numbers. And they changed to using letters, regular language, because it's really hard to remember, 9 or 10 or 12 or 16 numbers to type out as they expand how many digits there has to be in an IP address. So now you can see, okay, here's HTTP or HTTPS, the protocol language, and then it might say www. The name of the website, which is called the domain name, and then .edu or .gov or .com, and that last part after the dot is actually also called the domain, the upper level domain, just names the type of website that it is. So you can't get a .gov website if you're a movie studio or something. You can't get a .edu address if you are a waste management company. You have to be a university or a high school or something like that. However, almost everybody can, or really everybody can get a .com address. So you'll see that many universities have .com addresses for athletics or the bookstore or whatever. We have a couple of them that are running on .coms. So just to point out another point of contention, the internet is different than the World Wide Web. That's a different thing. The internet is the series of interconnected machines. The World Wide Web is really just a series of documents that sit on the internet. So if you look at a website and you don't see that www in the address, you're on the internet, just not on the web. But if you see the www, you're on the web. For most of us, for our daily activities, it doesn't really matter what that is. But if you're setting up a service, especially one that's web-based, you have to be conscious of which part of the internet you're on. And then services like email or file transfer protocols are also on the internet, but they're not really part of the web, although you might access them through the web. So if you have a Yahoo email or a Gmail email, you are accessing that through a portal that's on the web, but the transfer of the information itself happens just on the internet. If that makes sense to you. So there's a massive amount of data being created and transported around the internet, and the problem is that we are soon going to run out of space. So just like your plumbing can only handle so much water in your house, the internet can only handle so much data, and things like movies take up massive amounts of space. So the biggest database in the world right now is YouTube, and you think about all the video that's being uploaded every second, and it's staggering. So a group of organizations, including the government and some universities, are trying to build an internet too, meaning they're creating a new backbone, which is a term that your text talks about, a superstructure, the main line of communication for the internet going forward. And there's a lot of debate over who should control access to that, because the internet has been open, or relatively so. Obviously, your internet service providers like Comcast or AT&T sort of dictate your personal access to it, but it is open to anyone. Well, in the internet too, a lot of companies want to limit access. So, for example, somebody like Verizon or Comcast wants to limit the amount of space that a service like Netflix can take up without paying them extra. And so they would end up doing the same thing to consumers, that they would want to charge you extra to have access to the faster internet. And in business, speed is key. If you have a faster connection, you can move data to your clients faster or to your other offices faster, and that's becoming a big point of contention. So that's just kind of a quick overview of what's going on in Chapter 4. It gets into, again, a lot of the heavy technical stuff. And feel free to contact me with any questions about any of that, because it can be a little confusing. Take care.